Welcome back to Python to AI, Episode 3. This is where the real coding starts. Look at this program. It asks for two numbers, it adds them, and it tells me 25 plus 25 equals 25, 2,525, not 50, not even close. By the end of the next 20 minutes, you will know exactly why this happens and the one-line fix that prevents it. You will also know the 4 data types that every Python program and every AI model is built from. Here is the path. Variables, 4 types, strings, numbers, booleans, the type of function, and the trap that breaks the program you just saw. Start here. A variable is a labeled box. You saw that phrase in Episode 2, and it is the phrase I want you to keep. A variable is a box. You give the box a name, you put a value inside. Python remembers both. Creating one takes one line. Name equals quote Alice quote. Done. No declaration, no type annotation, no ceremony. Python looks at the value on the right, quote Alice quote, and figures out the type on its own. The value is text, so the box holds text. If I instead write age equals 30, Python sees a whole number and the box holds a number. This is called dynamic typing. Here is what it means in plain English. In some languages, Java, C, C#, you have to tell the computer the type before you use the variable. You write something like int age equals 30. In Python, you skip the announcement. The type travels with the value, not with the variable name. You can even reassign the same name to a different type. Age equals 30, then age equals quote old quote. Python does not complain. The name age just points somewhere new. A few rules for naming the box. Use lowercase letters and underscores. User underscore name, total underscore score. You cannot start with a number. One name is invalid, but name one is fine. No spaces, be descriptive. X tells me nothing. User underscore age tells me everything. One tripwire before we move on. The single equals sign in Python does not mean is equal to. It means assign this value. Read name equals quote Alice quote as name gets the value Alice. When we actually want to test equality, is this value the same as that value, Python uses a double equals sign. We will see that in beat 7. For now, single equals one direction, right to left. Python gives you 4 core types you will use every single day. There are a few more, but these 4 carry 90% of the work in this course and in real AI code. First, str, short for string. Strings are text. Anything in quotes is a string. Quote hello quote Python quote. Even quote 42 quote written inside quotes is a string, not a number. That last point trips people up. We will come back to it. Second, int, short for integer, a whole number. No decimal point. 42, -7, a million. And here is a nice touch Python gives you. You can write a million as 1_000_000 with underscores as visual separators. Python ignores the underscores. They are just for your eyes. And one fact that matters later in the course. Python integers have no size limit. 10 to the 100th power is a valid int. Your laptop might take a moment to print it, but Python will hand it back without complaint. Third, float, short for floating point. A number with a decimal, 3.14, -0.5. These are stored using the IEEE 754 standard, which is the same format NumPy and every deep learning framework uses. That detail becomes important in Module 2. For now, just decimals are floats. Fourth, bool, short for Boolean. Named after George Boole, the 19th century mathematician who invented the algebra of true and false. A bool has exactly 2 values, true with a capital T or false with a capital F. Python is picky about the capital letter. Lowercase true is not a Boolean. It is a name that does not exist, and Python will throw an error. 4 types: text, whole numbers, decimals, true, false. That is the toolkit. Now let us use them. Text first, strings, because text is everywhere. Natural language processing, prompts for LLMs, labels in a dataset. If you learn one type well, make it this one. The first thing you want to do with strings is join them. Python calls that concatenation. You use the plus sign. Quote hello quote plus quote comma space quote plus quote Alice quote plus quote exclamation quote gives you quote hello comma Alice exclamation quote. It works, but it gets messy the moment you have 4 or 5 pieces. The modern way is f-strings. You put a lowercase f before the opening quote, and then any variable you want to insert goes inside curly braces. F quote hello comma space curly brace name curly brace exclamation quote. Python replaces the curly brace expression with the value at the moment the string is built. The result is quote hello comma Alice exclamation quote, exactly what you wanted. In half the typing, f-strings arrived in Python 3.6 back in 2016. Every Python version you will run this course supports them. They are the default way to format strings. You will write thousands of these. Now, indexing. Strings in Python are sequences of characters, and every character has a position called an index. The first character is at index 0, not 1, 0. This is a universal convention in programming. Every serious language since C counts from 0. For the string quote Python quote, index 0 is P, index 1 is Y, index 2 is T, and so on. You pull a single character out with square brackets. Word square bracket 0 close bracket gives you quote P quote, and you can slice out a range. Word square bracket 0 colon 3 close bracket gives you quote PYT quote. Characters at positions 0, 1, and 2. Notice it stops before 3. The end index is exclusive, not inclusive. This confuses people for exactly one day and then never again. Finally, len. The built-in len function tells you the length of a string. Len open paren quote Python quote close paren returns 6. You will use len on strings, on lists, on anything with a length for the rest of your career. Numbers next. Python supports all the arithmetic you would expect plus a few operators worth calling out. Plus, minus, star for multiplication, slash for division. 10 plus 3 is 13. 10 times 3 is 30. Nothing surprising there, but look at division. 10 divided by 2 in Python gives you 5.0, not 5, 5.0, a float. Regular division in Python 3 always returns a float, even when the math works out to a whole number. If you want integer division, where Python drops the decimal and hands you back a whole number, use 2 slashes. 10 /3 is 3. The fractional part is gone. The percent sign is the modulo operator. It gives you the remainder after division. 10 modulo 3 is 1, because 10 divided by 3 is 3 with 1 left over. Modulo is how you check if a number is even or odd. N modulo 2 equals 0 means n is even. You will use it constantly. 2 asterisks together, star star, is the power operator. 10 star star 3 is 10 to the third, which is 1000. Most languages make you call a function for this. Python makes it an operator. Now, int versus float, 10 is an int. 10.0 is a float. Mathematically the same value. In Python, different types. The operator double equals tests mathematical equality. And 10 double equals 10.0 returns true. Python does the comparison numerically. But type of 10 double equals type of 10.0 returns false because the types themselves are not the same object. You can convert between them. Int open paren 3.7 close paren gives you 3. Notice, 3 not 4. Python truncates toward 0. It does not round. If you want proper rounding, use the round function, which we will meet in a later episode. Float open paren 5 close paren gives you 5.0. That is the arithmetic toolkit. 7 operators. 2 conversions. You have everything a math homework assignment needs. Booleans. The last of the 4 types, and arguably the most important because every decision your code ever makes comes down to true or false. Comparisons produce Booleans. 5 greater than 3 is true. 5 less than 3 is false. 5 double equals 3 is false. And that is the double equals for comparison, not the single equals for assignment. We warned you back in beat 3. 5 exclamation point equals 3 is true. That is not equal. Greater than or equal is greater than equals. Less than or equal is less than equals. You combine Booleans with 3 logical operators, and or, not, true and false is false. Both sides have to be true for and to be true. True or false is true. At least one side has to be true. Not true is false. It flips the value. Here is a real example you might actually write. Checking if someone can enter a venue. They need to be 18 or older and they need an ID. Age greater than equals 18 and has underscore ID. If both are true, can underscore enter is true. That line reads like English, which is a big part of why Python is the language of choice for beginners. One more concept, and this one matters for the next episode: truthy and falsy values. In Python, any value can be evaluated as a Boolean in a context that expects one. Like an if statement, the number 0 is falsy. Any other number is truthy. An empty string is falsy. Any non-empty string is truthy. None, which we will meet next episode, is falsy. Empty lists, dicts, sets, all falsy, everything else, truthy. You will use this constantly without thinking about it. If name is shorthand for if name is a non-empty string. That is why the term exists. Two tools before we build: the type function and the input trap. The type function tells you what type any value is. Type open paren quote hello quote close paren returns the text less than class single quote str single quote greater than. That output looks intimidating. Class str, but all it means is the type is str. Do the same for 42. You get int for 3.14, float for true, bool. When something in your code is not doing what you expect, the first debugging move is always the same. Call type on the suspicious value. And now the trap. This breaks every single beginner, and we called it out in the cold open. The input function reads a line from the user's keyboard. It always returns a string. Even if the user types the characters 2 and 5, Python hands you back the string quote 25 quote, not the integer 25. Which means if you write a equals input, b equals input, print a plus b, and the user types 25 twice, Python does not add 50. It concatenates two strings. You get quote 2525 quote. That is the program from the cold open. The fix is one function call. Wrap the input call in int. A equals int open paren input open paren quote enter a number quote close paren close paren. Now a is a real integer. Now plus means addition. Now 25 plus 25 is 50. You will write this pattern 100 times in this course. Time to build. Our project for this episode is a data type explorer. The user types in any value. Our program guesses what type they meant. Why is this interesting? Because input gives us a string no matter what. Our code has to inspect the string and figure out what the user was trying to type. Start with an input call. User underscore input equals input. Whatever they type comes in as a string. Now the logic. First check. If the lowercase text is literally the word true or false, we have a Boolean. Convert accordingly. Second check. If the text contains a period, try to read it as a float. Third check. Strip a leading minus sign if present, then ask if every remaining character is a digit. If yes, it is an int. If none of those match, leave it as a string. It is text. Finally, print 3 lines. The value itself. Its type as reported by type dot double underscore name double underscore, and the label we detected. Run it. Type 42, it prints int. Type 3.14, it prints float. Type true, it prints bool. Type hello, it prints str. Then try to break it. Type 3.14.15. What happens? Type the word true with capital T. Does our lowercase check still catch it? These are the questions the code answers, and playing with them is how you actually learn. The full file is in the GitHub repo. Link in the description. That is episode 3, 4 types. The type function, and the one-line fix for the 2525 bug. Next episode, control flow, if statements, loops, and the moment your code starts making decisions. Subscribe and hit the bell. Drop a comment telling me what you want to build with a I read everyone.